Students, welcome to this session on disaster management. This is the first session. We are meeting the first time. I'm your internship coordinator for the disaster management concepts and topic. In this session, we'll see what is disaster management, what are the types of disaster management, and apart from that, we'll also see why civil engineers should have the knowledge of disaster management and that how disaster management internship can be helpful in your career. So we'll see everything in this first session, and we have subsequent session wherein we'll bring in a lot of information on disaster management and how disaster management skills can be incorporated in engineers, and we can hone these skills to get prepared for job because internships are the importance of internship is that you get a skill, not only to mention on your resume, but such that you can become technically skilled. You get the knowledge which help you ultimately in getting a decent and good job. Because as we all know, why this internship has been incorporated in the BTech syllabus. The one of the important reason is that through internships we want to gain the knowledges required in the job and those knowledge which are left in the college study, because in the college when we are learning in the college, the chapters and the topics that are discussed by our learned professor are mainly focused towards getting a good marks in the university. You pass in the paper, you get good marks in the university, and that you pass out with flying colors. But internship has been added into your syllabus so that you become job ready. That is what we are doing in this session of disaster management. So, in this session, we start with a critical skill for engineering careers. How disaster management is a very good and important skill for engineering career. This presentation will explore the importance of disaster management for engineering student in general, and highlighting its relevance in the job market and providing an overview of key concepts, strategies, and also the emerging trends. We will also see the role of disaster management from the civil engineer's perspective. An essential aspect of civil engineering is disaster management. Civil engineers have a crucial role in building resilient infrastructure, buildings and dams, bridges that can withstand natural disaster. So the ultimate goal is that when we are designing or when we are building infrastructure, those infrastructure should be built with all the considerations such that it can withstand the natural disasters like earthquakes, etc., floods. Disaster management is an integral part of civil engineering. Building a competitive edge, disaster management skills for successful career, as we just now discussed, that if you have the skills, you have the knowledge of disaster management, you have an edge over others because when we see that how many engineers are getting out of engineering college every year, there are lakhs of engineers and civil engineering is core, and every engineering college these days have civil engineering, computer science engineering. These are two engineering which are almost in every college. So a lot of students are passing out every year from engineering college. So what skill will make you have an edge over other civil engineers? So one such knowledge is the knowledge of disaster management. Because see, in building construction, because in civil engineering, most of you will go into the building construction. And if you have the knowledge of how those buildings should be constructed, which will prevent the building, which will prevent the infrastructure from falling or getting destroyed by the natural disasters, it will have certainly a very good edge, and employers will value such employees who have the knowledge of the disaster management. So, what are the opportunities for civil engineers in disaster management? So, there are structural engineering, building construction, as we have already discussed, geotechnical engineering, and environmental engineering. So, when we talk about the structural engineering, it is the designing and strengthening buildings and infrastructure to resist earthquakes, floods, and disaster. So, buildings should be constructed in such a way that if there is a flood, if there is an earthquake, or there's some other natural disaster, the building should resist those disasters, and the implementation should be done in such a way that it does not fall apart. In geotechnical engineering, analyzing soil conditions and designing foundations and retaining structures to prevent landslides and soil liquefaction. So these are the very important technical terms which are important. Then we have environmental engineering, wherein developing strategies for storm water management, flood control, coastal protection to mitigate the impact of climate change. Also, that is also very important. So the opportunities for civil engineers in disaster management can be categorized into three parts: the structural engineering part, wherein the designing and a strengthening of building and infrastructure is important. And then the soil condition, analyzing of the soil condition and designing foundations comes under the geotechnical engineering category. And the environmental engineering, because as the buildings are getting constructed, as there are more and more forests are getting destroyed and new areas are coming up. So there's some climatic change, and those climatic change will bring disasters. So it is important to develop strategies for a storm water management, flood control, etc. The importance of disaster management in engineering job. Why is disaster management very important in engineering job? Risk assessment, safety and resilience, environmental impact, as we just discussed, and infrastructure planning. So engineers must assess potential risk and design structures that can withstand natural disasters. So you can see that there are regions, there are areas which are more prone to like earthquake. There are regions which are more prone to volcanoes. There are regions which are more prone to floods. So engineers must assess the potential risk. It is very important that you assess the potential risk. If the infrastructure is getting constructed in an area which is prone to flood, so you have to keep in mind while developing the infrastructure, how to prevent it from flood. If it is in a volcanic area, or if it is in an area which is prone to earthquake, then it has to be potential assessed, all the risks that are involved, and the design structure should be considered in that way. Disaster management knowledge ensures the safety of people and infrastructure during and after disaster. So, when there is an earthquake or when there is a flood, there will be a loss of like people. The people safety is in question. The infrastructure will getting destroyed. So disaster management knowledge ensures the safety of people and the infrastructure before and after the disaster. And then comes the engineers play a vital role in developing resilient infrastructure that can withstand and recover from disaster, and the environmental impact. And engineers must consider the environmental impact of disasters and develop solutions that minimize damage and promote sustainability. So these are some very important factors and the importance of disaster management in the engineering jobs. Now, what is disaster management? We have discussed so many things, but actually, what is disaster management? So, we have to understand that disaster management is the process of planning, organizing, and coordinating resources to prevent, mitigate, prepare for, respond to, and recover from disaster. So, when there is a disaster, when there is an earthquake, the building must be constructed in such a way that it can prevent itself and it can recover very fast from the disaster. So, disaster management is the process of planning, organizing, and coordinating resources. You have a lot of resources as a civil engineer. So all those resources can be utilized to plan and organize and coordinate such that the infrastructure can respond to the disaster as well as recover from the disaster. And what are the key elements? It encompasses a wide range of activities, including risk assessment, preparedness planning, emergency response, and post-disaster recovery. So all these things comes under the disaster management. A wide range of activities, including risk assessment, preparedness planning. You have to assess how much risk is involved. Suppose the building is getting constructed or the infrastructure is getting constructed in a densely populated area. So you have to plan accordingly that if there will be a disaster, what risks are involved. You have to assess those risks. You have to pre before this disaster occur, you have to prepare so such that in case of emergency, you will how will respond? What are the safety measures taken? So these are the key elements. So we have to understand what is a disaster, what is disaster management, and what are the key elements of disaster management. Now, what are the types of disaster? When we talk about the types of disaster, it can be classified into natural disasters, man-made disasters, and technological disasters. So, there are some natural disasters. Natural disasters are earthquakes, floods, hurricanes, wildfires. These comes under the natural disasters. Then there are some man-made disasters. These are human-induced disasters such as accidents, explosions, chemical spills, like someone is driving rashly on the road and it hurts a lot of people. It meets an accident or there is an explosion. So due to a bomb by terrorists. So these are man-made disasters. So as an engineer, we have to plan for all such disasters. Then there are some technological disasters. These are caused by technological failure such as nuclear accident like in Bhopal. Many of you must have heard because it happened 20, 30 years back. There was a gas strategy and many people lost their lives. So that is technological disaster. There was a gas leakage and there was a great loss of people. And you can say there was a lot of mishappening that happened at that time. Then there can be some nuclear accidents, there can be oil spills, there can be cyber attacks. So all these are the technological disasters. So when we talk about disaster, usually we talk only about floods and hurricanes and earthquakes, but there are three types of disasters if we talk about. The disasters can be natural disasters, then it can be a man-made disasters, and it can be disaster. So, as an engineer, we have to be prepared for all types of disasters. So once we have come to know that there are different types of disaster, then the second important thing is the preparedness and response strategies. So we have to develop emergency plans that outline procedures and responsibilities of different scenarios. Then we have to conduct regular drills and simulations to test plans and ensure everyone is prepared. If you have you might have heard that there was a mock test of a terrorist attack in New Delhi. That if there is a terrorist attack, how will every system work? There's a mock test of on the airport that if a flight crashes, how the system will respond to it. So we have to conduct regular drills and simulations to test plans and ensure everyone is prepared. Then we have to train personnel in first aid, uh, then CPR and other essential skills for handling emergencies. So there should be people who have got training in the first aid, so that before they can be rushed to hospital, or before the doctors come, or before the police come, depending on the type of disaster, the affected people get some relief. Then we have to establish communication protocol and ensure access to vital information during disasters. We have to establish communication protocols. That means we have to establish rules to ensure access to vital information during disasters. Why disaster occur, what about the reason for disaster, so that it can be prevented in future. And we have to create evacuation routes and identify safe gathering points for personal and community members. You must have seen that in malls and in big buildings, there are exit routes are marked for emergency. Then on the elevators, it is written that during earthquake, you should not use this elevator. Instead, you should use the staircase. All the malls, all the big buildings, all the places where large people gather, they has to have some evacuation routes, so that in case of disaster, people can save their lives. So it is very important that we know what are the types of disaster, and we are prepared for it. In case of disaster, how to respond, how to prevent people life and their financial belongings, etc. Everything needs to be protected, and it is the role of the engineers, so that they prepare in such a way that in case of disaster, the life can be saved, their belongings can be saved. Then coming to the next very important thing is the risk assessment and mitigation techniques. It is very important that you assess the amount of risk involved. Like suppose there is an airport getting constructed, or suppose there is a bridge getting constructed, or there is a high building 20 story or 40-story building getting constructed. So you have to assess as an engineer what are the hazards, what are the dangers. Then you have to assess the vulnerabilities. Then you have to assess estimate the risk. Then you have to develop the strategies for mitigation, and you have to implement those mitigation strategies. So we have to be very prepared, because we cannot just create the infrastructure, develop the infrastructure, and forget. We have to go for a long-term plan, and we have to identify hazards. We have to assess the vulnerabilities. कहाँ से there can be leaks, there can be attacks, there can be dangers are chances of dangers. Then we have to estimate the risk. Then we have to develop mitigation strategies and implement those strategies so that there is minimum loss during the disaster. Then very important thing is disaster management in the infrastructural planning and design. So you have to ensure structures can withstand earthquake, seismic design, then flood control measures should be there, designing flood barriers and drainage system to prevent flooding. You might have heard few months back that there was during rain a lot of students got stuck in a coaching center in Bangalore, and there was huge loss of life. So why that happened? Because the coaching center was in the basement, and during flood, when a lot of water came, there was no proper route to come out. So the students got struck and there was a huge loss of life. So when designing the infrastructure, you have to make it in such a way that the flood barriers and drainage systems should be there to prevent flooding. Then there can be wind. So you have to prepare for the wind resistance, building structures that can resist high winds and hurricanes, and there can be fire. So implementing fire suspension systems and designing buildings with fire resistant materials. So buildings should be constructed in such a way, or the infrastructure should be constructed in such a way that due to fire, there should be minimum loss of life and property. So, disaster management in when we talk about the disaster management in infrastructural planning and design, there are four steps. Step by step, you can see, and there is a seismic design, the flood control measures, the wind resistance, and the fire safety. These are the important things that needs to be considered. Now coming to earthquakes, because see, earthquakes and floods, these are two important aspects when these are two important disasters which are bound to happen. So we have to be prepared for earthquakes as well as for floods. Apart from other, like fire is also there, but earthquake and floods are two very important natural disasters. So, what needs to be done? Reinforced concrete with high strength steel bars is used for columns, beams, and walls, increasing strength. So, strength needs to be increased, and flexibility of the building should be, the infrastructure should be done. Then, a special bearing or pads are used to separate the buildings from the ground, reducing the impact of seismic waves. So these are called base isolation. The building floors and the ground has some special bearing of pads or some you can say gaps which are used to separate the building from the ground, reducing the impact of the waves. And steel frames are designed to bend and deform under stress, preventing catastrophic failures during earthquakes. So these are very important aspects of earthquake. We are just discussing in brief, because as we move on with the session, we'll see everything in detail. But we have to consider earthquake, because earthquake are bound to happen, and many infrastructure get destroyed during earthquake. So if the building is in earthquake zone, it has to be taken into consideration the reinforced concrete, the base isolation, and the ductile framing. Then when we come to flood, then flood mitigation, drainage design plays very important role. The strong water management is required. We have to design and implement retention of ponds, swales, and permeable prevents to reduce runoff and prevent flooding. Then designing efficient drainage systems with underground pipes, ditches, and channels to quickly remove excess water. Now, what happens when there is a flood or when there's a heavy rain? Then the area should be constructed, or the infrastructure should be constructed in such a way that the water the drainage system should be such that all the excess water gets removed very quickly. Similarly, the construction of flood walls and levees to protect critical infrastructure and residential areas from flooding. So, when we talk about flood, then flood mitigation and drainage design should be considered during the infrastructure design and planning. And when we are talking about earthquake, then earthquake resistant construction techniques should be used. So these are two very important things. Now, when we talk about the sustainable building design for disaster resilience, there are 3 points that needs to be discussed. One is renewable energy, then the water conservation, then the green building material. So, what are these? Using solar panels, wind turbines, or geothermal energy to reduce reliance on fossil fuels and ensure power supply during emergencies. These are the topics that are for sustainable building design and disaster resilience, implementing rainwater harvesting system, water efficient fixtures, and drought tolerant landscape to conserve water resources, and then using sustainable and locally sourced material that have lower environment impact and are less likely to be damaged during disaster. So these are the 3 points that are very important to be considered for the design of disaster resilience infrastructure. Now, coming to the conclusion, we have to understand that integrating disaster management in the project life cycle is very important. What happens when we many times when suppose a building is getting constructed, the build once the building gets constructed, then the builders and then the engineers try to add those features which will prevent us from disaster. This is a very wrong strategy. So the good strategy is that the before the building is getting constructed, all the plans should be made in advance. So the project life cycle should integrate disaster management right from the initial stages. The disaster management concepts should be taken into consideration, which are risk assessment, conducting thorough risk assessment to identify potential hazards and vulnerabilities during the planning stage itself. Then, during the design and construction, incorporation, resistant design features and building codes to ensure structural integrity and safety, and operation and maintenance, implementing ongoing maintenance programs and emergency response plans to ensure infrastructure remains operational during disaster. So every infrastructure, every project has its life cycle that starts from the risk assessment phase and to the operation and maintenance. So there are three stages. First is the risk assessment, then is the design and the construction, and then is the operation. Operation phase has a longest part. Design phase has the time duration till it is getting constructed. And before the infrastructure is getting constructed, it is very important to assess all types of risks so that it can be incorporated during design. And once the infrastructure is designed, during the operations, during its usage, all the maintenance programs and emergency response plans should be ensured so that the operational the infrastructure remains operational during disaster. What are the emerging trends and future challenges in disaster management? When we talk about the emerging trends and future challenges, there are climate change, rising sea levels, extreme weather events, other climate related disaster pose significant challenges. Then technological advancements such as AI, drones, sensor networks, and are transforming disaster management. Then urbanization, the increase Increasing concentration of population in cities requires more sophisticated disaster management techniques and global interconnectivity. Disaster management efforts increasingly involve international cooperation and collaboration. So these are the future challenges in disaster management. The climate is changing as we all read these news every day. Then there are a lot of technological advancements happening, urbanization happening. So we have to be connected globally to face all those challenges. So, what is the conclusion? Disaster management is a crucial skill for engineering professionals, ensuring safety, resilience, and sustainability in the face of natural and human made disasters. By embracing emerging trends and proactively addressing challenges, engineers can play a pivotal role in building a more resilient future. I hope you all enjoyed this session. You must have got some basic information on disaster management. We'll meet again in the coming session to discuss and see more on disaster management skills and its implementation. Thank you very much.